Start recording. Hello, everyone. Happy New
Happy
Year.
New Year. Hi,
Yeah.
Kobe.
Hey, good to see you. Um,
See
this
you.
is our 70 meeting, number 70. Today, Jan 14. Uh, one second, I'm going to admit people. So we have a very packed agenda. So let's start with the intro. If you are new to the group, we meet every month. I do my best to bring some interesting ideas that you can take and use it. Uh, Sometimes we'll have guest speakers. Anyone that would like to speak is more than welcome. So let me know if you want to have anything presented in the session. We had that multiple times. So yeah, feel free to contact me anytime. Um, this is our agenda. I quickly want to talk about a few things that I would like to share with the team, with the people on the call. Then Rich has something to present. We'll have one CPP quiz and then recap on the last session and then the main course, which would be the Decorator Pattern. So again, my name is Kobe. You can find a couple of CPP cast sessions that I was a guest in, and Dorothy has a book that I was reviewing. It's actually a great book on object oriented, and I work in NVIDIA. So, few things. First of all, if you need CLion licenses, I have few of them. Please approach me in Discord or any other like LinkedIn or any other way that you would like. I have a bunch of them that I would like to give away. This is basically you get a voucher, you go through the purchase process, but you just punch the voucher and you get it for free. So this is my favorite IDE, and if you need one, please let me know. So that's one thing. The second thing is I'd like to provide some heads up. Uh, Packet, which I have a lot of contact like POCs that I'm working with, uh, approached me a few days ago about promoting a couple of C++ books, new C++ books. One is Debunking C++ Myths. It's the left one. And the other one is Minimal CMake. So Packet has few CMake books. In September, we had review on one of them, the second edition of one of the CMake books. So they have another new book that was published in Jan 2025, and the Debunking C++ Myth is December. So heads up, we didn't have time to get the vouchers for this meeting. Is CLion better than Xcode or VS Code? I don't have any experience with Xcode. I do have with VS Code, and I just like the battery included kind of approach in CLion. So I personally like CLion better. So, but I don't know. It might be kind of a taste, but you can try it out. You just approach me. I'll give you. So in the past, people try to use the vouchers in an incorrect way, which I wasn't aware of, and it just didn't work. So the vouchers are not the CLion license key. The vouchers are for the purchase process. Like you edit, you browse to the JetBrains uh, website, and you purchase this. You go through the process of purchasing CLion, and then you punch in the voucher, and then it should be free. So so again, let me know if you need one. Discord is probably preferred. It's easy for me to transfer the vouchers. Okay, so heads up, next month we'll get some vouchers for these ebooks. They We have a couple options. Maybe both of them will be. Some of them are just vouchers for free ebooks, and the other one is kind of a bundle and a discount. So so just wait for that next session. Okay, so Rich Yonts, which we already had a pleasure of him presenting his book. By the way, congratulations, Rich. This is not a MIP anymore. It's actually published. So congrats on that. Again, I'm gonna meet people. So would you like to present? I'm gonna stop my share and you can present.
uh, I'm the last person to know that my book was published. I stepped outside my door today and there were 2 boxes of books. I didn't even know we were finished with the editing phase. But there they were.
I'm just a messenger, and because when we went through this process of me reviewing the book, I own the ebook, so I get notifications of MIP, and I get notification when it was published. So, congrats! It is published.
Yeah, thank you. Okay, let me present here.
Okay, let me stop presenting. Go.
All right. Okay. I don't know. Am I presenting?
Not yet. I don't see anything yet.
Okay. Entire screen. There we go. That should be it.
Something is coming in. Yes, good. We have.
Okay. Request for volunteers. I'm doing a PhD dissertation, and I'm working on automatically solving static code analysis warnings. I've done a small amount of work on that. And what I want to do is get some volunteers that will look at proposed solutions and give their feedback. Is it good? Is it bad? Does it introduce issues? All you have to do is give an opinion. And once opinions are in and the code is doing what it should, then I can write up a conclusion of what we discovered. It's very simple. It's a document, and I would send it to anybody that has interest. You mark off for each solution on a scale 1 to 10. If you like it, if you don't, if you have concerns, and there's an area to write in concerns or a better solution. So I'm trying to just find out the feeling and the usefulness of the approach. And there will be an eligibility and informed consent document for anybody that wants to volunteer. That I'm required to do that. The school says I cannot abuse my human subjects, so that's part of it. There'll be 12 warnings that are selected and proposed solutions. And that's it. And that's about as simple as it is. And here's my email address at the school. If you're interested, email me, and I will put this address in the Discord channel so you don't have to remember it. Just to give you the heads up, there's no remuneration. You will not directly benefit from the research. Free to opt out of any or all questions of the whole study, no consequence. Nobody will say bad words about you. And the only thing that would identify you to me is your email address. That is not part of the study. It doesn't go anywhere. It stops with my computer, and that's it. So you're protected, you're safe.
So no credit cards, no social security, none of these.
None of that stuff.
None of that stuff. Okay. Sounds safe.
And if you happen to put your social security number in, I'll just ignore it.
Okay.
Now, I'm not sure about credit card numbers, so I might use those.
So question.
Go ahead, Gubby.
I don't know if people have any questions. I'll have one. So how much time does one person need to dedicate, like roughly, in your opinion, for that?
Say between a half hour and an hour.
Okay, that's
all of you are skilled developers. You'll look at a solution, you'll say that's that's wonderful, or you'll say that's not wonderful. I think you'll know that within the first half of a second.
Okay.
And yeah,
Okay. Good. Perfect.
yeah,
Okay. Thank
yeah.
you.
Thank you.
My pleasure.
Appreciate it.
Yeah. We'll publish that so it hits a lot of people. So help you.
Thank you. Thank you.
Awesome. So let's continue. Okay. Oh, let's do some just one CPP quiz. It's very easy just to warm up. So let me present the page. CPP quiz. I have, by the way, the backlog of the CPP quiz is crazy. Uh they publish every almost every week. Anyone? Okay, let's do it. What do you think gonna happen here? This is they all moved to like they all questions moved to CPAPAS 23. What do you think? This should be easy, even though it's kind of medium difficulty, but should be straightforward. What do you think happened here? We have a type def, and we're looking at the type ID of both of vector int and the kind of the type ID of the of TV int. Is it 1 or 0, or it's not compiling, or undefined? Shout your you. That's fine to be to get 1. Yeah. So we're not getting a new. It's an alias. We're not getting a new type. Type def doesn't. So usually, if I want a different type, there are multiple ways to do that. But there is one particular library that I really like. The name of the library is named type, which I really like. And just demonstrating, just reading the code, it's not a lot of code to read. Just reading the code uh, is really nice to see how to create a strongly typed library. So it's a very nice library. So named type, I'll paste it. Let me paste it into the Slack channel right now, so you can take a look at that. Let's see discussion. Okay, you have it in the Slack channel. Okay, let's stop that one. Go back here. Okay, so I want to have like 4 quick slides before we go to the actual agenda with the decorator. Just a recap on last session. If you didn't if you didn't attend or didn't watch the last session, don't worry. It's just very quick 4 slides. It's just I think I owe a bit more explanation because I think I just didn't have time to show other ways that would fail. And but we did have a follow up. And thank you for everyone kind of bringing up all kinds of options. But we did have a follow up in the Discord session, a Discord channel, I mean. And I just want to highlight one thing. So I'm gonna do a very quick recap. The idea was that we have a duplication of code, and we want to map like everything that below 5 or equal to 5 to 128, 6, 7, 8, 9, 10 to 256, and the rest to 512. We want to map range to a constant. And the most important thing is that we want to pass we want to create a framework where there is a runtime value, n is runtime value, and we map it to a specific integral value that we can pass to a template function as a template argument, non-type template argument, but something that can be used in this context. So there are a few options, and if you remember, if you were in the session, watch that. Few people suggested map and all, but I didn't have time. It's really hard to squeeze a lot of material into 1 hour, so I didn't have time to show why the other parts are failing. uh, However, in the blog post that i I tend to have a blog post, usually few days. It takes me a few days to write one recap of the session. So, and I'm using Martin's blog, Volbord blog. So I have a write up, but just to recap, um, if you think about just an unordered map, this would not work because I cannot just pass m of 5 to the template function. It's not going to work. And there is a C link in the blog post, so that's not going to work. I need a constant. I need like a compile time constant. So compile time constant could be integral constant in a map, but obviously an integral constant of size t and something is its own type. So I can't really, I can't like just put that in the value as a value type, because there is no such type. Like 128 and 256 are two different types in an integral constant. Then I think GC, you mentioned CPAPA's weekly episode 233, having a const expert map, which is close, but still, again, I have compiler explorer links, so you can play with it. So even with a const expert map, when I want to pass the value using this syntax, map at I, it's not going to work in the context of what I'm trying to do with passing a constant to a template parameter. Again, it's a non-type template parameter. You can see that here. But it doesn't really matter. I'm unable to do that. So if you remember, if you were part of the previous session, we went through a lot of hoops to get that done, and it's working and all. It's working very well. But it's not as simple as, oh, I'm gonna create a const expert map and I can just use the value in a context of passing that to a non-type template parameter. So the rest of the details, there's a lot of details, would be in the blog post and in the session. Feel free to take a look at that. Thanks for the feedback in the discussion over the Discord one. By the way, if you need a Discord, before I forget, maybe let me do that. Give me a sec. I'm going to paste the Discord updated invite in the messages, so you can take a look at that. Okay. The main thing. I have 40 minutes. I think I can squeeze that in. So decorator design pattern. How many people actually using decorator, like the gang of 4 decorator design pattern? How many had a chance to use it? How many people know about this design pattern? I don't think it's like, I bet people know about it, but I don't think it's being used a lot. Though if I'll have a couple of slides toward the end of the deck. Even if there's some elements in the standard, in the CPAPA standard library, that if you're using it, you're basically using the decorator pattern under the hood, and you might not even know about it, that you're doing that. So if you don't know about it, this is hopefully this is the right place for you to get a feeling of what it is, how to use it, why it's useful. So usually when I create a slide deck and I'm trying to start from the beginning, I say, okay, what does Wikipedia say about X, Y, and Z. So decorator pattern. So this is what the Wikipedia says. It's in object-oriented programming, a decorator pattern. By the way, it's a gang of 4. It says that it's one of the 23 well-known design patterns. Allows behavior to be added to an individual object dynamically without affecting the behavior of other instances of the same class. By the way, this is sound like paradise. You add functionality to a class without actually touching the class. This is already something in Solid, the O in Solid, the open-close principle. Open-close principle says you want to have a system that you can extend, but you can't, or you don't want to change. Changing a system, meaning you need to retest it, but changing a system means you actually changing functionality of your classes or your functions. You want to design your system to be able to extend it without affecting the existing system. So, and the singular responsibility principle, this comes as an additional benefit, because if you look how we structure the decorator pattern, each additional added functionality is in a separate object type. So it doesn't, it's kind of agnostic or orthogonal to the other parts of the system. And this is beautiful. And this is something that sounds like paradise, right? It's you add functionality without touching any of the system. You can think about other parts of, like, other design patterns like visitor and maybe strategy. We'll talk about strategy towards the end. They have their own merit, but this is really kind of a good solution if you structure your system to be able to add decorators as you evolve the system. Okay, so usually when I say decorators, happened to my son when I talk to my son. My son is also a software engineer, and I talked about Python decorators. We're talking about two different things. So Python decorators, but I bet people know about Python decorators. I know. I'll tell you a secret just between us, no one hearing. I really like Python. So this is one of the languages that I really like, and I study it as much as I can after C++. It's just a fun language in my opinion. Python decorators are different. They might share kind of the same idea, but it's a language feature. First of all, it allows you to modify or extend the behavior of a specific function. It's basically behave the way I see it, it's like a high order functions. It takes a function as an argument, gives you some new function that adds something maybe before, maybe after, depends on what you want to do. And it has like this syntax of the at. How do I feel about Java? So I'm not a Java person. I had opportunity to work in Java for a very little time. I bet it's a great language for some domains, but I don't have enough experience. I recently listened to, there is a podcast named Core Recursive, and it talked about kind of a Java evolution, Sun Microsystems. Very interesting episode in Core Recursive. So I'll find the episode and I'll send it in Discord. It's something very nice to kind of listen the history of evolution of Java and Sun Microsystems. I used to work on Solaris 2.5, 2.6 in the end of the 90s, so I familiar with Sun a lot. Okay, so here's an example of Python decorator. Just a kind of a small detour. You have this syntax, my decorator, and say hello is basically a function that passed. You get a high order function. When you say hello, this is what you being printed. There's something before and something after that I can do. It's very convenient, and it's one of the advanced features in Python that we all should probably use. Let me see. Yeah, so Paulo says that besides C++, Python is the first used language by C++ devs. Definitely, uh, I use it in my day job. You know that there's a lot of AI stuff. There's a lot of front ends and a lot of stuff happening in Python. Python is very important for AI. So yeah, it's I really like Python. I think it's a fun language. So okay, the Django 4 Golf, Django 4 decorator pattern. It's a bit different. It's a structural design. You want to dynamically add or just add behavior to objects. You can compose them. Composability is the key thing. If you want to know where to use it, orthogonal composability. That's one of the things that you need to think about. You can create a set of decorators that are self-contained, and you can just compose them to something that works together. It's just beautiful. You'll see the example. It's just a very nice pattern. The interesting pattern, I'll probably repeat myself multiple times because that's important. Decorator classes themselves, or we'll see some UML. So decorator classes themselves, they implement the same interface as the object that they decorate and basically inherit from. And then they add their own behavior before, after, whatever, delegating to the wrapped object. So we'll see some UMLs and we'll see some code. So that if that's not clear, we'll make sure it's easier to understand. Okay, so here's a Python, very simple Python Django 4 decorator that an AI did for me. Just this is not my code. This is an AI code. Okay, give me a Django 4 decorator example with coffee. Have milk and sugar decorators, and that's what happened. And this is working, by the way. So this is from I think Copilot or something like that. So here's what happened with decorator. I think this is easy to understand. It's simple. We have coffee. Forget about the abstract base class ABC. Just ignore it for a second. But that's there's a base class, and simple copy has a cost 5. So this is basically the interface cost. And then we have some intermediate object. This is the decorator that holds the coffee. It doesn't do anything with cost yet. Now the actual decorators. There's a milk, there is a sugar. Basically, we want to know what is the cost if we add sugar, what is the cost when we add milk. So the interesting part is that each of the decorator is using whatever they hold, the coffee that they hold, they call cost. And that could be multiple calls that happens. And then they do something more. So whatever the cost is, we'll add 1. And the milk decorator is whatever the cost is, can be multiple decorators that were being invoked. We'll add 2. Just imagine that we can chain decorators. There's just one here for each. So sugar decorator takes coffee, the actual coffee that has 5. And then my coffee with sugar the cost would be 6. Because it takes 5, this is the cost, plus 1, it's 6. Same idea with milk. And I could have milk and sugar. Like I can have 5 plus 1 plus 2. I can chain all of them. The reason I can chain all of them is that they share the same interface. So the decorator doesn't need to know much. It just knows that it inherits from coffee, but it also holds coffee. So the decorator has the same interface, but it knows that whatever it holds has a known interface. It happened to be the same interface, which is inconvenient. And that's it. So when we look at the C++ code, the C++ code would not be very different, just syntax. but it's going to be very similar ideas to what we see here in Python. Just to recap, Python decorators, they are working on functions. The Gang of Four is working on objects. It's kind of more high level. It's kind of more complex because it's function versus objects. The decorators in Python are kind of more syntactic. Gang of Four creates multiple class types. It's creating more types versus the Python one. Flexibility. The Gang of Four just allows you to chain this, just easily chain a lot of decorators just more easily than the Python one. But that's fine. But Python, the decorator in Python is awesome. There's like so many decorators from LRU cache to anything like time and time it and all of that. There's a lot of things that you should, if you work on Python, make sure that you handle decorator a lot. It can save you a lot of time. It has a lot of applicability in logging and so on and so forth. In Python, everything is object. That is also true. This is also true. Okay, so let's take a look at. I just copied that from the Gang of Four book. This is the Gang of Four decorator diagram. This is the UML, and I must say that when I was learning the Gang of Four, that happened many years ago. I was introduced to the book around end of 90s, beginning of 2000. There's a lot of things that I didn't understand, especially a lot of the code was Smalltalk and all, which I didn't know, so I needed to kind of think hard on the actual implementation. But one of the things that used to confuse me was this relationship. Like how come the decorator is aggregated? This is not composing, but aggregating, if I'm not mistaken, component, but also inherit from component. And why do we need this intermediate class? Because you can see there are concrete class on like the leaf class. There is a concrete class that doesn't have a decorator. We'll see some code with that. And there is a concrete component, but it's actually coming from a decorator. And we can use both of them in the same context, but this one is just straight inheritance, nothing special. And this is going through a decorator. So something is added to the operation. So that was this part, this relationship, this looks like cyclic relationship. We used to confuse me. So hopefully I'll talk about that, and I'll show some examples in C++ to kind of make it clear. I want to mention something. This whole kind of description of the decorator is inspired by this fantastic book. For me, if you ask me about what is the best modern C++ design, there's not a lot of there are few design patterns books. This is by far the best. Like if you happen to, and I have the printed book, also the ebook. It's not cheap. They are very expensive. Like they are 50, 60, 70 bucks, I think. They're worth every penny. So if you don't have access to this book, my recommendation would be to read that. It's going over so many important items, and it's all written in modern C++, period. Like there's really nothing to say about the code, in my opinion. It's well-written code. So grab the book. Yeah, this is a fantastic book, and Klaus is a great speaker. If you have a chance to either watch his talks or participate in one of his talks, and I had the pleasure to be in cppquiz a few years back and participate in his one of his talk. He's a fantastic speaker. So he he writes like he speaks, so that's fun actually. So it's a very fun read. So go get the book. Okay, so one of the guidelines use decorator to add customization hierarchy is again this whole thing is inspired by that. So there is a design. So it starts with a design problem. The design problem is I have this structure. So there is a system, there is an item, it has a price. The price is there as a protected member, double taxed, and the derived classes just override that. So the price is a virtual, and you have concrete class, and there is a new requirement. There are different rate of tax or maybe different rates of discounts, and the problem, one of the problems that is of this design of this specific author, the author of the design, as an example here, is that tax is already embedded in the item, but maybe in some places there are no tax. How do you compute different tax if it's already there? The other problem is that tax is protected, so everyone has access to that, and uh, having it protected as a function is better than having that as a member. There is a C++ guidelines about having protected members. It's discouraged. Protected members are kind of public in disguise. So the best approach is placing them behind functions. So don't have the member as a protected, but have the functions. So that will make it much bulletproof for the future. So let's think about options of adding different tax, maybe adding discounts, adding all kinds of different level of price manipulations. Okay, there's a price, and but we might need to compute other stuff in order to get the final price. It's just like the Python example where there was the coffee cost, and we want to have milk, or we want to have sugar, and we want to have combination. We want to maybe just milk, maybe just sugar, maybe combination of two, or maybe just coffee, just espresso. So we want to have all of that, and we want to make it in the way that it's not intrusive, that we don't have explosion of types and very hard times to create these combinations. One option, you remove the tax from the base class, you start putting a middle hierarchy for this specific items. So item 1 and item 2, you can think about coffee and, I don't know, muffin, right? So item 1 and item 2 are just different items, but they have price and they have tax. So some of them are, and they have discount. So try to imagine what happened here. You get explosion of types very, very quickly. The other part is that you have computation that would be similar in multiple types of the derived classes. And it's insane. Like, this is exploding very quickly. What happens if you want to change something? You need to change it in different places. Yes, you can have a strategy as a place where you have a common, and this is a good approach. Have it as a common, but we talk about strategy. Strategy has it is a solution, but it's a less it's more intrusive and kind of less beautiful than the decorator. But that's one way to have all the common computation in a strategy class and plug it into the items. The problem, that one of the problems that not shown here but shown in this, what happened if you want combination? Combination means a whole different type. You start changing the system quite a lot, and you need to test it, and duplication would happen, especially if you are in a hurry. Duplication would happen. So that's not ideal. So I already mentioned that. This is a slide of what I mentioned. You can definitely have a separation of concern by having a strategy that does computation that is common across different types, and have this strategy plugged into either via template, or you can have a runtime polymorphism. Both of them works. They have pros and cons for both, but this is one option. You What happens if you don't want any manipulation on the price? You end up with the null object pattern, which is a very common pattern that not common, it's a very common plugin to the strategy pattern. So a null object is something that you can use in the strategy context, but it does nothing. It does no manipulation on, let's say, on the price. When you tax would do some manipulation on the price and give you a new price that is taxed. Discount would give you a new one that is discounted. But the null object is something that gives you the same price. And this is a very nice, if just Google or just search for null object pattern, you'll get, at least the first one would be Wikipedia showing you the idea behind it. The nice part about null object in the context of strategy is that you don't have this weird if else, if this is null pointer, do this, if that, but because you always have an object, you don't have if else, you just execute the function, but the function might return the same thing. So it's a very nice plug-in into the strategy pattern. So this is kind of summarizing what I said. If you use the strategy pattern, you always need a strategy, which means you need at least a null object. It's not super convenient. Sometimes you just, in the decorator, we'll see, if you don't use a decorator, just the type, in the instance of the type, and that's it. You don't have anything else. There might be some code duplication with strategy as well, though strategy is used to kind of take the common parts and put it in one location, but you'll end up with some scenarios, you might end up with duplication in different strategy types. You might duplication of code. Strategy doesn't solve the idea of composing or combining types. So for me, h of x and g h of x and f g h of x is the way to think about composing types. And there's a lot of people in the community that they are big fans of composing types, and Bendin is one of them, by the way. And he was a guest at least once in the meeting, in the meetup. So the composing doesn't really work with strategy, and it's intrusive. It's intrusive in the sense that if I want to introduce strategy, I need to go and start adding, removing, and it's kind of violating that. But it's kind of better. It's kind of between decorator and explosion of types with the first approach, but it's less suitable for what we're trying to do here. So we go back to the Gang of Four decorator. So you need just to remember the few rules of decorator. First of all, there's an intermediate, or kind of there's neither level in the hierarchy. Usually want a hierarchy to be very shallow, just two levels. In decorator we have another one, but that's fine. There's a big reason for that. There's a justification for that. But just remember that decorator is kind of a middle type in the hierarchy. It inherits from the component. So essentially, it implements the same interface. So if I hold something that is a decorator, it has the same interface as the component. So it behaves like the component. In addition, it takes an instance. This is why we have this. It takes an instance and keep the instance in, so it can call the function, the operation, and then add something on top of that. That's the important part to remember. So the whole uniform interface is helping us to not to we don't need to remember multiple interfaces. Oh, we inherit from one interface and invoke a different interface. It's all the same interface. It's very convenient. So hopefully this may be confusing for me maybe many years ago, but maybe it's not confusing anymore. This part of inheriting, but also holding. The Python code already showed that, but we'll see some C++ code. Okay, so open close principle, the O in solid, that's the important part. Just to recap, we have a decorator item in between the interface, which is here, the item. We don't have anything in that there were no members here. There's no protected data members. We have function like methods, like function members, member functions, but no data members. So we have this price. We hold item. Remember, we have this arrow. So we hold and we call this price, and one decorator. So if you remember here, there's a decorator component. One decorator can have a discount. The other one would be computed tax. So that's how we achieve different, and they behave as an item, but an item that has some other functionality that when I call price, something happened to the price before I get that. Let's see some code. Okay, so we have class item, which is basically match this guy, and it has price as a virtual function. That's it. Now we have the middle class, the decorated item, which is this type in between the leaf and the base class. It inherits from item, but also holds item. Okay, so I can have a specific item. This item can be internally can be a decorator itself. I'm passing that when I'm constructing this item, keeping it here. If someone wants to access the item, it's accessing the item through protected data members, but doesn't have access to the item itself this way. Like it doesn't, not in the protected like we had before. Remember that though it's not showing here, it still have the price interface because we inherit. One thing that you probably notice is that we're not implementing the price here. We're not implementing. So you cannot really create from that point, you cannot create a decorator item like this. You cannot like create an instance, right? This is, by the way, I made it the virtual destructor and all of that. Just make sure that you have it. Is this clear why we cannot create a decorated item? We cannot create one because it's still inheriting a pure virtual function. So we cannot create it. Like if you try to create a decorator item on the heap, on the stack, it doesn't really matter. It's not going to compile because you're not implementing the price pure virtual function. Okay. Next. So we have a concrete, remember having a decorator pattern doesn't preclude having just a concrete item. So I can have some item 1 and item 2, and it has all kinds of functionality. Inheriting from item makes me, of course, if I want to create a concrete type, a concrete instance of this type, I need to override the price. So both of them overriding the price. So at that point, this leaf class is something that I can instantiate. So I have this system full of these items, and I'm fine. But I have also the decorator. So this is where I can extend the system to accept more functionality. Okay, let's take a look. Discounted. So discounted, inheriting from inherited from the decorator. So basically, we are looking at this concrete decorator now. It takes an item, gives it to the decorator, because why? Because the decorator holds that. Okay, and this item can be anything, because we're talking about we are working on an interface level. This item can be anything. It can be either a concrete component or something, or some other decorator that is already doing something. So we'll see an example. And discounted is taking the price from whatever we have so far, just calling the price function on item, whatever item it is, and it's doing something and returning that. So if you're already seeing the opportunity to chain decorators that call price, and price is doing something by calling price all the way to something that just return a value, and this value is going through some manipulation until we get the final value. This is the beauty of the decorator. This is why this is such an amazing pattern. Let's take a look at main, because this is where everything now is going to be connected. Okay, so let's take a look at two items. So I have a unique pointer of item, could be auto, but actually this would be unique pointer of item, not auto. So I have this make unique of item one. So I'm creating item one. There's a name and there's a price, and I'm creating a text. So this is the decorator. So this is item. This is a leaf. I'm creating a leaf, and I'm adding a decorator on top of that. And this is 0.07. And this is what happened when I call item one price. It goes to the decorator, says, "Give me the price." The price, the decorator, which is taxed, goes to the price function of what it's holding. It's holding an item one, gets 19. And then it adds 7% on top of that. And this is what we get. And this is beautiful. Now, here's the beautiful part where I can actually chain this. I can have tax and discounted. So when I call item two price, it goes to taxed. And tax says, okay, I'm holding what? An item. The item might just happen to be discounted. This discounted also has a price. It's okay, what do I hold? I hold item. Item has 9999. Returns that to discounted. Discounted is doing the discount, which pass it to the taxed. And this is what you see here. The 9999 times 0.8, it's a 20%. And then 1.19, you get the final value, which is 95105. And this is beautiful. I didn't need to change item. Item is still just having one price. I just needed to have a decorator of discount and decorator tax, and I can compose them. They compose very well, which is really nice. Now, if you remember at the beginning of the session, I told you that if you working on the standard C++ library, in some areas of the libraries, they're actually using something similar. And I don't have more than one slide on that, but take a look at the C++ STL allocators. Monolithic is the example here. So you can actually chain them. You can have one pool that when it's exhausted, go to another pool all the way to whatever you chain. In this case, null memory resource. If you don't have memory, you in the array bytes, it's exhausted, and it's very, very flexible. And GC had one session a few months back, also on allocators, and it's basically doing the same. So take a look at that. This is also an example in the standard library of using Decorator. So I have a couple slides before we end. One is the shortcut of the Gecko for Decorator. So first of all, it's another entry in the hierarchy. It's another indirection. So every time you have a decorator level, it's another indirection. And the book has some performance measurements. So please take a look at the book. Almost for every pattern, I can't remember from top of my. I read the entire book. Almost for every single pattern, Klaus is performing a benchmark on various types of patterns. So it might have some penalty. If you have a lot of interactions, it's a critical path. So just remember that. One of the things that are funny is that you might decorate something twice. You might have double tax. So obviously, it's something that might be maybe hard to debug and confusing. Order, in some cases, order might matter. It depends. It depends on the use case. Order might matter. Yeah, this is true. Not always. It depends on the use case, but order might matter. This is a good point. I don't have it as a bullet point. So, Jonathan, thanks for mentioning that. Okay. Summary. This is my last slide. It's 1 minute to 6. Inheritance or strategy, not always the answer. The book has a very nice story about a couple of engineers going to some guru in the company and asking for their advice about redesigning something. It's really funny stories to read. It's not the answer. It might be part of the solution. Inheritance, for example. If you need composition, think about Decorator. It might be your solution. It's non-intrusive. It's extensive. It's the open close principle in solid. Easily to reuse in the system, especially if you need to be reused in different contexts. In the book, I don't have it here, but the book has a comparison between, and it actually happens in multiple chapters, between adapter, strategy, and decorator. So Klaus, when he talks about a specific pattern, and the pattern might be kind of adjacent or very similar to other patterns, he explained the differences. And I personally needed to read multiple times in order to kind of get the whole thing to sync. And he has a lot of references to, hey, the CPP standard library has this function or set of functions that actually implement this pattern. So that's also a very nice thing to read. Indirection. Remember the indirection. This is one of the shortcomings. Measure might not be a big deal, but just measure. That's it. That's what I had for today. Hopefully, you have more knowledge now when talking about Decorator. And I had some Python. But that's it. Any questions or comments? People had a very good feedback and suggestion in the chat. We can follow up on Discord, by the way. Thank you, Jonathan. Okay. Yeah, I'm gonna have a blog post to summarize the whole thing, and see you next time. Happy New Year. Thanks for joining. Take care.
Thank you.
Thanks.